Welcome to another new video. Today we take a step deeper into the world of artificial intelligence, exploring how machine learning and deep learning are revolutionizing photovoltaics. Can you imagine a solar plant learning by itself and optimizing its operations in real time? That's what these technologies can achieve. We will explore how these powerful tools can improve generation forecasting, predictive maintenance, and operational efficiency of a solar plant. Machine learning is a branch of artificial intelligence that allows systems to learn from data without needing to be explicitly programmed. In the context of photovoltaics, it is used to optimize energy production, predict failures, and improve operational efficiency. Supervised and unsupervised learning. In supervised learning, we train a model with labeled data to make future predictions. In unsupervised, the system looks for patterns in the data without clear instructions. Photovoltaic applications. Machine learning can predict energy production based on weather data, detect inverter and module failures, and optimize predictive maintenance. Machine learning offers a competitive advantage in solar plant management by automating and optimizing processes that previously required manual intervention. While machine learning uses simpler algorithms, deep learning mimics the structure of our brains, using neural networks to solve much more complex problems. Artificial neural networks. Neural networks are composed of layers of artificial neurons that process information in several stages. Each layer extracts key features from the data, allowing more complex patterns to be identified. Deep learning applications in photovoltaics. Deep learning can be used to predict the degradation of solar modules, identify faults in solar tracking systems, and optimize the tilt of panels in real time. Neural networks are ideal for analyzing large volumes of data and finding patterns that would otherwise be impossible to detect. Let's look at some case studies of how machine learning and deep learning are already being used in the PV industry. Energy production optimization. One example is the prediction of energy generation based on weather data. By using machine learning models, plant operation can be adjusted to maximize production. Predictive maintenance. Machine learning can also analyze inverter operating data to predict when a failure will occur, allowing maintenance teams to intervene before it happens. Deep learning for fault detection with thermal imaging. Thermal cameras can capture images of solar panels. Deep learning models can detect hotspots and defects in modules by analyzing these images. These examples show how these technologies not only predict problems, but also optimize the overall operation of a solar plant. To implement machine learning and deep learning in a PV plant, it is essential to have a robust infrastructure in place to process and analyze large volumes of data. Data collection. The first step is to collect relevant data from sensors, SCADA systems, and panel images. This data is the basis for training the machine learning models. Cloud processing. Most deep learning projects are processed on cloud platforms, such as AWS or Google Cloud, which allow large amounts of data to be managed and complex models to be trained. Automating decision-making. Once trained, models can be integrated into plant monitoring systems to automate decision-making, such as adjusting panels or generating alerts. With the right infrastructure, AI can transform the way we operate our solar plants, improving efficiency and reducing operating costs. As we have seen, machine learning and deep learning are key technologies to optimize the operations and maintenance of photovoltaic plants. If you want to know more about how to implement these tools in your projects, feel free to contact me on LinkedIn. These technologies are taking PV to a new level of efficiency and automation. Are you ready to apply the power of machine learning and deep learning to your solar plant? Connect with me to get started.